So in this video, we'll be able to understand the power associated with active elements, whether the voltage source is actually consuming or is delivering. That is, a battery, whether it is charging or discharging, a current source, whether it's actually a source or whether it is consuming charges. So let's see power associated with active elements in this video. Myself Mohan BS, Assistant Professor, Department of EEE, SJBIT. So here I have given a circuit, right, where we have two meshes. So let us consider mesh 1 in clockwise direction, right, and let us name this as I1, and similarly mesh 2, let us write this as I2. So here I'll not be explaining how do we solve for mesh 1 and mesh 2, right. So rather let us say that you have applied mesh analysis or nodal, right, and you have found out these circulating currents as I1 and I2, right. So as you can see, these currents are actually 5 amp and 1 amp. So you can solve by yourself and check the currents as are they same or different. So remember, I have applied mesh analysis and I found this current in clockwise direction as 5 amps, and similarly here I have applied current in clockwise and I found the current as 1 ampere. Now from here we'll just try to see how do we find power. Now we know the three formulas for power is I square into R or V square by R, and last one V into I. So let us see how do we find power associated with 20 volt batteries and then followed by power associated with 7 volt battery. Now we'll use the formula V into I, but you can see I've highlighted here a parenthesis also in between V and I, right. So let's try to understand what exactly is that. Now as we apply in the currents in clockwise direction, mesh 1 current I1 travels upward through this branch, right. The current mesh 1 travels upward through this branch. That means the current I1 travels through 4 ohm and then 2 ohm, right, and then it travels through 28 volts, right. It hits negative polarity first, right. So then how do we incorporate this negative sign, right, or what is the equation for this voltage? So as you can see in the equation here, I have written the modulus of, that is the magnitude of voltage and magnitude of current. So the voltage magnitude is 28 and the current magnitude is 5. Then what we have to do in this parenthesis, as the current hits negative sign first, we have to write that, we have to incorporate that polarity and write it as negative, right. So current hits negative, thus we incorporate negative sign and we will multiply, we get the answer as minus 140 watts. So negative sign is always associated with power delivered. Okay, so this is your energy source or power source. Similarly, let's see power associated with 7 volt. So as we know the formula, it is V into I, and you have to incorporate the polarity of the current that hits first, right. So as we have seen, the current I1 we have taken in clockwise direction. The current travels through 1 ohm towards right and then comes down to 7 volt. So as the current comes down, it hits first which polarity? It hits positive polarity of 7 volt first. Thus we have to incorporate positive with respect to current. We write the equation now as V is nothing but 7, and what polarity? As you can see, I have used parenthesis here. So in this parenthesis now we have to substitute positive, and the magnitude of current is 1 ampere, right, 1 ampere, and as we multiply we get as 7 watts. And positive power is always associated with energy absorbing, right. So we can say here the 7 volt battery is actually charging and 28 volt battery is discharging, right. So let's see a small exercise so that you can understand the techniques much better, right. So here if I ask you to compute the power associated with each part, so let us say we'll solve one by one, right. In figure 1, let us use the formula, that is, we know that P is equal to V and then bracket and then I, right. So what is V? V, as you can see, it is 2 volt. The magnitude of V is 2 volt. So I'll write it down as 2, right. I'll write the parenthesis, I'll write the content in parenthesis later. Let us write I. Now what is I here? So I, you can see it is plus 3. So let me write I as plus 3. Now the current hits which terminal first? As you can see here, current hits positive terminal first. Thus I write here positive, right. It is not 2 plus 3, rather it is 2 into positive of 3, right. So then this becomes 6 watt, right. And similarly for figure 2, we know P is equal to V into parenthesis and then I, right? What is V? As you can see, the magnitude of V is minus 2. So I write V as minus 2, right? Into, we'll see what should we write in the parenthesis later. And then what is current? Current is minus 3. So I will write this as minus 3. Now let us analyze, where does this current hit first? Which terminal or which polarity? It hits positive terminal first. So in the parenthesis I will be writing positive. Thus the answer is 6 watts again. Right? Now let's see the last case. Right? The formula is same. P is equal to V into parenthesis into I. Right? Now what is V? So as you can see now V is actually plus 4. Right? So write down plus 4. Right? Parenthesis we'll see later. And then what is I? I, you can see it is minus 5. Right? So let's write minus 5. Now what is parenthesis? Where is the current hits? The current hits again positive terminal first. Right? So we'll write here plus. And now your answer is minus 20 watt. So that means this is actually delivering and these two are absorbing energy. Right? So this is how you can use the formula to find out whether the energy is being absorbed, the power is being absorbed, or power is being delivered. Right? So what you can do is, here you have to find the power associated with these elements. Right? I'll leave this as an assignment for you just to analyze. Thank you for watching the video. Please do subscribe the YouTube channel to enhance your knowledge further.